Hi. So I just wanted to show you briefly the optional exercise. I added autoencoder as an object exercise. So I'm just saying the following code attempts to reduce the dimensionality of MNIST using autoencoder. We do not expect you to run the experiment, just run it and look at the figure. Try to run it. So I'll just try to run this. And then we'll just think for a while. Just load the dataset. So right now it's loading the dataset. And then you see these are the original digits and these are the reconstructed digits, and you see them flimsing a bit around. So these are digits not in the data set, and you see the loss going down, and then this half on the left, they're real digits, and then the last part is reconstructions of those digits. So this would be a reconstruction of this, and this would be a reconstruction of this, and this guy would be a reconstruction of this guy. So these are also not in the training set. These are digits from the test data set we didn't use for training. So I mean, this is just a very simple run and then see what happens, and it looks kind of cool. So it's just kind of a motivation for dimensionality reduction. It doesn't have to take more than 5 minutes. This is why I wanted to include it. So yeah, I also write this element. We'll talk about dimensionality reduction at the lecture, focusing on principal component analysis and the Johnson-Lindens-Ross lemma. The above example shows the power of dimensionality reduction. So I just briefly made like this thing that the TA can choose to just briefly talk about, just give the intuition of the architecture of an autoencoder. If not, it's also fine. I mean, I just wanted it to give it as an option for the TA. So I also added it as an optional exercise. So the reason is I already had the code, and I think when you see this run, you kind of get an idea of how the autoencoder works.